Okay. So number 55 says a spherical ball has a mass of 3.475 grams and a diameter of 9.40 millimeters. What is the density of the steel? And they don't really ask us what type of units they want, but we can work it out. So I'm moving things around so I can see things on my screen. Okay, so this is number 55. And we've got that the mass is 3.475 grams. We've got the volume of a sphere is 4/3 pi r cubed. I don't like the way it's written. That's the way it's written. It's hard to tell whether that 3 is on the top or the bottom, the way the book has it written. So this is much clearer. Where r is the radius, and we have that the diameter is 9.40 millimeters. So let's go ahead and say that we want the density in grams per centimeter cubed, because that's the normal way of getting the density of a solid. It's either grams per centimeter cubed or kilograms per meter cubed. Those are normal units for densities of solids. Okay, so if I want these types of units and the density is, or the diameter is in millimeters, first thing I'm going to do is I'm going to convert the diameter to centimeters. So I've got 9.40 millimeters. And this is something you all should have an idea of, that there's 10 millimeters in 1 centimeter. So this ends up being 0.940 centimeters. And then we have the volume, which is 4 pi r cubed over 3 is 4 pi 0.940 centimeters cubed over 3. And we can estimate this answer. This number here is really close to 1. So 1 cubed is 1. 1 times pi is 3. 3 times 4 is 12. 12 divided by 3 is 4. So the answer should be close to 4, maybe a little under, I imagine, because this times this is not 1. So when I plug this into my calculator, let's see what we get. 4. And some of the things that you may wonder about in this formula, is any of this defined? And the answer is yeah, the 4 and the 3 are pretty well defined for a sphere. When you type pi into your calculator, what kind of significant figures does this have? Because my calculator just says pi. Watch what happens when I put enter. I get 3.1415. The point here is that when you use pi from your calculator, you're going to get like 10 significant figures.
I have a question.
Yeah.
So I thought we were doing, it's 4 times pi r cubed, the radius.
Ah, thank you.
Okay.
So that means that the radius, good catch, is 9.40. Well, I'm going to do this. The radius is the diameter divided by 2. So if you divide this by 2, it's going to be close to 5, right? But not quite 5.
Yeah.
So 4.7. Now,
I think I already know where I went wrong with my decimal points. I didn't convert.
now let's take a look. Yeah, let's take a look here. What mistake did I make?
You need a 0.
I need a 0 here because this has 3 zig figs, and so should this. So now I can fix this up. 470, 470. And you can see we're going to get 3 significant figures here. And so I have to take back my estimate of this being around 4. Instead, it's going to be a lot smaller. In fact, I think it's going to be less than 1. All right, so let's go ahead and finish this very quickly here. So I've got 4 times pi times 0.47 times 0.47 times 0.47 divided by 3. And I do get 0.4349 centimeters cubed. And I'm using the arrow to tell me that that's where I would round, but I'm keeping an extra digit along. And so finally, the density is mass divided by volume, which is 3.475 grams divided by 0.4349 centimeters cubed. And so I get 7.99 grams per centimeter cubed. Okay.
Thank
All
you.
right. What's next? Go ahead, Marco.
Hi. Don't we just have to convert to centimeters again? From the new value in millimeters? Sorry.
How was that?
Oh, I just thought like we got a new unit, 4.7 millimeters, but we didn't convert that to centimeters. Or I didn't.
Right here, just crossing that out and that's the conversion to centimeters.
Oh, okay.
And that, of course, gets used here. And it was carried through.
Okay.
Okay.
Thank
All
you.
right. So this is the kind of stuff you should show on your exam for something like that. You should show having the radius. Don't do it in your head. Make sure you're following the significant figures. And actually, I would rather see this. I like that, but then do this. And notice, which part of this do I not have the units in it? And the answer is whenever I have the raw formula. You don't have units there. But once you start putting values in for like R and for D, you better put units in. If you don't have your units in a problem, I don't care if you got the correct numerical result. I'm not going to count it as being correct. So you'll lose a point if you don't carry your units, or more if you don't carry your units through your calculations. And you might think to yourself, oh my, will I have time to do that on the exam? And the answer is absolutely, but only if you're prepared to do the problems. If you're not prepared, then you might very well not have time. Okay. Who's next? There's a lot of you in here. Let's see, 1, 2, 3, 4, 5, 6, 7.
I have another one if no one else does.
Go ahead.
On page 50, question 16.
Number 16, did you say?
Yeah.
That's one that we did in the earlier part of the day or in the other classes. So that's a perfect question to ask in the evening because you weren't in the earlier part of the day. So let's take a look at number 16. So here's how I would do 16. Notice that the question is which occupies a larger volume. They don't actually ask you for the volume. They said which is a larger volume. So one of the things that would help you is if you know that density is mass divided by volume. That means that volume is equal to mass divided by density. So we can calculate the volume of each of these based on their density and their mass. Now we don't have to use this formula. So here I'm going to show you a way to get the volume of the water without using this formula. So I'm going to start off with 600 grams, and I'm going to put a W here for water. And actually, I'm going to write out water times this right here. Now, for this right here, this says that 0.995 grams of water is equal to 1 centimeter cubed of water. So when you write things out like this is called a number, this is called a unit, and this is called a label. Unit, or excuse me, number, unit, label. Now, in the best of worlds, if I want to get the volume out of this, I would like to multiply by something that has grams of water on the bottom and centimeters cubed of water on the top. And you may recall from an earlier lecture where we had an equality like this, where you have 12 inches is equal to 1 foot. And I can write 12 inches over 1 foot is equal to 1, or I can write 1 foot over 12 inches is equal to 1. And the reason this works is because 12 inches is 1 foot. So when you have the same amount divided by the same amount, you get 1. And then when you invert that, you get 1. So here is an equality. So I can take either one of these and write it on top and the other on the bottom, and it's equal to 1 because they represent the same amount. So here, I'm going to put the 1 centimeter cubed of water on top, but more importantly, I'm going to put the 995 grams of water on the bottom so that these cancel. Okay, now looking at this problem, how many significant figures are we allowed at the end? And the answer is 1. Because 600 has only one zig fig. So I can do this one in my head. 0.995 is close enough to 1 that this will go into that 600 times. So I get 600 centimeters cubed of water. So what I want you to do now is I want you to set up the 600 grams of lead. And I want you to do the same thing with the density of lead. And then when you're done, just give me a check mark or a thumbs up that you're done. You don't have to share your answer with anybody, so we won't put you on the spot. And if you feel like you can't do this and you're having trouble with it, still give me a signal that you're ready to move on with a yes or a thumbs up. I'm going to wait till I see a few thumbs up or yeses before I move on. And remember, a yes or a thumbs up just means that you're either declaring victory, or you're declaring that you think you have it, or you're declaring that you're ready to move on. Okay, I think I saw about 3, so that's good enough. So I'm going to write 1 centimeter cubed of lead over 11.35 grams of lead. So the grams of lead cancel. And here I can see that that goes into that about 60 times because that's around 10. But since that's a little bit more than 10, maybe it's more like 50. Now notice I don't have the precise volume. I don't know what it is. Can I answer the problem with the information that I have? And the answer is absolutely. Which occupies the larger volume? The water. Okay, now let's use the formula and see if we get the same answer. So we're going to put D, actually, I'm going to use this right here. VW, volume of the water, is the mass of the water divided by the density of the water. So we have 600 grams divided by the density of the water, which is 0.995 grams per 1 centimeter cubed. And here I don't feel as obligated to put water here because I have these symbols W here, which means water. And here I think we can see that the grams cancel. We still have 600 divided by 1, which is 600. But how do we justify that this is going to be centimeters cubed? And the deal is that when you take something like this and you move it across the line, it changes the sign. So I'm going to do this because that's essentially what we have for that centimeters cubed. I'm going to multiply this by centimeters to the -3 times centimeters to the -3. And what happens here is that becomes 1. Then I'm going to multiply this times centimeters cubed over centimeters cubed. And that times that is centimeters to the 0, which is 1. So we get centimeters cubed. You don't need to show all that work. I'm just trying to show you that this centimeters cubed does end up being in the numerator. Okay, so the volume of the lead, PB, is equal to the mass of the lead over the density of the lead. Now, to me, this way is easier for me to follow unit-wise. This way, I kind of have to justify to myself why the centimeters cubed ends up here as centimeters cubed. All right, so either way works. As long as you're showing your units, showing your work, that should be okay. Here, if you're going to use this method, you want to use this formula and show it. Here, we're not really using a formula, so we're just using what's called dimensional analysis, so there's no formula to show. Okay, so there's that one. Number 16. What did I do with that? Oh, there it is. Okay. Other questions? Okay, so let's do some problems from the around page 50. And my goal is to show you how to do these problems and to show you some information you should know, get a little practice with significant figures, carrying digits through operations, and also talking about scientific notation. So this is problem 2 on page 50, as you can see. The temperature of the surface of the sun is 5.5 times 10 to the 3rd degrees Celsius. First thing I want to tell you is that when you write this out like this is called scientific notation. Now, scientific notation does not mean that you have some number times 10 to some power. It means specifically this. So this n represents the 5.5, this e represents the 3, and this 10 represents that 10. When you write things in scientific notation, the n must be less than 10, and it must be greater than or equal to 1. And you can see that 5.5 fits right into this. So we cannot have an n equal to 15, nor can we have an n equal to 0.5. Okay, E is a whole number. So it can be any number like -3, -2, -1, 0, 1, 2, or 3. We don't want to ever use E as a decimal like 1.5 or 1.6 or 8.2 or a fraction. Whole numbers only. Second thing I want to tell you about this is that if E is greater than 0, then the overall number is greater than 1. And if E is less than 0, that means negative. Then the overall number is less than 1. So if I want to take this 5.5 times 10 to the 3 degrees Celsius and write this out without the 10 to the third, I can see that because that's a positive value, greater than 0, the overall number is greater than 1. So the other thing is that 3 tells me I need to move the decimal 3 places. So if I move the decimal over 3 places like this, I get 0.0055. If I move the decimal over this way 3 places, I get 5500. Since that's 10 to the third, this one has to be correct and this one doesn't. So the way to remember which way to move the decimal is really simple. If that's a positive value, move the decimal so the number becomes bigger. If it's a negative value like this, move the decimal so that the number becomes smaller. And when I say the number, this number part, these are the same value. One's written in decimal form, one's written in scientific notation. So this value here is really that. And the next thing I want to tell you is that you use n to count significant figures. So if we look at this n, how many significant figures does it have? 2. The first 5 and the second 5, 2 sig figs. And when we rewrite it in decimal form, you'll see that it still has 2 sig figs. Next, I want to show you.
Exponent though is positive.
What's that?
The exponent 10 to the 3.
That's positive. If it were negative, you'd see a negative next to it. So when you don't write a symbol next to it, it's assumed to be positive.
Right, but then you switched it to negative.
Right, as an example for when you move the decimal to the left.
Oh, okay, sorry.
Yeah, this is just an example for when you would move the decimal the other way. If it's negative, make the number smaller than the original number. You're not really making it smaller, but you're doing what you're supposed to do here. And if it's a 3, you're going to make it bigger. And it's the same way for when you do the reverse. If I want to write this in scientific notation, I move the decimal over 3 times and I get 5.5. Now, should this be a positive or a negative? It should be positive because the original number was bigger than 1. And when I write this in scientific notation, I move the decimal over 3 places until I get a number between 1 and 10. I moved it over 3 times. Should it be positive or negative? The original number is smaller than 1, so I make it a negative. Okay, so temperature conversions. You need to memorize these. In this case, the temperature conversion we're looking at is taking degrees Celsius and turning it into Kelvin. So memorize this formula. This is precise to the 100th. So in this particular case, we're going to take 5500 and add 273.15 to get the answer. And I'm going to write this out over here and do some addition by hand instead of the calculator. And I'm doing my addition the exact opposite of the way you're supposed to. You're supposed to start on the right and go to the left. But this is the sum of these two values. Now, the rule for addition and subtraction is that the precision of the answer is the same precision as the beginning number that's the least precise. So the precision of this number is good to the hundreds. That's right here because those zeros don't count. And this is good to the hundredths, which is right here. So I need to round to the hundreds. So to the right is more precise, to the left is less precise. So the 5 is less precise, and I'm going to write that down here, less, more. So this gets rounded to the hundreds because that's less. So when I round, I want to keep the 5 in the thousand spot. I want to keep the 7 in the hundred spot, but I have to look next door and see that that's a 7. So it becomes an 8. And then I put 0, 0. Now what happens if I put a dot 0, 0? If I put a dot 0, 0, that means we're being precise to there, and that's not what we want. So we write 5800, and that's precise to the hundreds. So this answer would be K is 5800. And this is the kind of work I would expect to see for a problem like this. The formula you're using, plugging the value in, and the final answer. If you're ready to move on, let me know and we'll move on. Give me a yes or a thumbs up. I don't care what. Okay. As soon as I see 3 of those, I'm just going to move on. So let's take a look now at problem number 4 on page 50, where we're going to make the following temperature conversions. So let me help you with A. A is going to be a little bit different. So we have K is equal to degrees Celsius plus 273.15. And I'm going to rearrange this so that I can actually get C on one side and everything else on the other, and I get this. Okay, so when I went from here to here, I just did it in my head. This is how I'm actually doing it in my head. I'm subtracting 273.15 from this side, and I'm subtracting 273.15 from this side. And I'm getting K minus 273.15 is equal to degrees Celsius. And then I'm switching the degrees Celsius to the left and the K minus 273.15 to the right. Because it turns out that if you have A is equal to B, then B is equal to A. So that's how I got here. Do I expect to see this work on your exam? The answer is absolutely not. So now I'm going to plug in the value. We have 77 minus 273.15. And we can estimate the answer. This should be around negative 200 because 273 is about 77 more than 200. So it should be around negative 200. And this is good to the ones. This is good to the hundredths. So I'm going to round to the ones. So when I plug this into my calculator, I get negative 196.15. And I want to round to the ones, which is the 6. And because what follows is 0.15, I round down. And this is the work I would expect to see for a problem like this. I don't even need to see the original formula. I need to see the formula that you're using and then how you're using it and then the answer. If everyone's okay with that, give me a thumbs up or a yes or some sort of sign. Okay, let's move on. So what I'd like to do now is I want you to do B and to do C, give you an opportunity to write out the problem as you know I expect you to do it on an exam. And when you're done, give me a sign. And when I say when you're done, I mean when you're done, or if you're ready to move on. Okay, we got a couple done. We're going to wait for a couple more. I can see that you might be having a little bit of trouble here, so I'm going to try and help you out. So maybe this will help you figure it out.
Meet your next pillow. Why do we make our pillow in the shape of a cube?
Oh,
I'll tell you. The problem with pillows is that you're trying to fit a round peg into
darn it. I found one with a commercial. This music's driving me crazy. I better see some thumbs up or something soon. All right, close enough. We got 3 thumbs up. We're ready to move on. Okay. So for letter B, we're going to write degrees Celsius is K plus 273.15. Notice an interesting thing here. It's degrees Celsius, but it's not degree K. So degrees Celsius is equal to, oh, I'm sorry. My bad. We're figuring out K. K is degrees Celsius plus 273.15. See, that Jeopardy theme music did it for me. So K is equal to 63 plus 273.15. So this is good to the ones and this is good to the hundreds. So I'm going to round to the ones. And I can see that when I add these up in my head, I'm going to get over 300, but not quite to 350. So I expect the answer to be somewhere in the middle there. So 63 plus 273.15. That won't work. Okay. So I get 336, and that's the Kelvin. For C, we're going to have Kelvin Actually, we're doing the degree Celsius. Degree Celsius is Kelvin minus 273.15. So degree Celsius is 1450 minus 273.15. And here, this is only good to the tens. So we're going to round to the tens and we get 1180. I believe that my calculator puts out 1177 or something like that. So we want to keep the 1, and the 7. But when we look next door, since that's the 7, this rounds up to an 8. And this is only good to the tens. So if we're good, give me some thumbs up or go ahead.
I have a quick question. Why to the tens again? Because it's less precise? Is
Right.
that what you said? Okay.
Yeah. Precision, the more you know about the smaller amount, the more precise it is. So 0.15 is more precise than 50.
Yeah. Okay.
Okay. The more you know about the right-hand side of the number, the more precise it is. Okay. So let's put that away. And let's look at this next one. The average lead pencil, new and unused, is 19 centimeters long. What is its length in millimeters? So we're going to use the conversion factor method. So the conversion factor method begins with something like this. This is an equality. And I think we all know this equality. I'm going to write it down twice. It's so important. Okay, I'm going to divide this side by 1 foot. And the golden rule in algebra is if you do that to one side, you have to do it to the other side. And it keeps it equal. So this becomes 12 inches over 1 foot is equal to 1. And I'm going to take this and I'm going to divide by 12 inches. So I'm going to divide this side also by 12 inches. And in this case, I get 1 is equal to 1 foot over 12 inches. So if you have any equality like x is equal to y, you can write x over y is equal to 1, but you can also write y over x is equal to 1. So that's the first thing you need to know about conversion factors. These are what I call conversion factors. This is an equality. The reason I call this an equality rather than equal is because sometimes you don't have the same units on each side. They might not both be linked. For instance, if you drive 50 miles per hour, that's an equality. For every 50 miles you drive, it takes 1 hour. For every 1 hour you drive, it equals 50 miles you've traveled. These are not the same type of unit. One's time and one is distance. So they're different types of units, but yet these are equal to one another. Okay, the next important factor is that these are all equal to 1. And the golden rule in algebra is what you do to one side, you have to do to the other to keep it equal. But the golden rule of math is if you multiply something by 1 or divide it by 1, you haven't changed it at all. So if we take 24 inches and we want to prove that this is 2 feet, I'm going to multiply this by 1 so that I don't change the amount. So am I going to multiply it by this one or this one? And the answer is I'm going to use this one because the inches will cancel. 12 goes into 24 2 times. Feet doesn't cancel. We've just proved that 24 inches is indeed 2 feet. So that's how you use equalities to make conversion factors and then use them to convert from one unit to another. So we want to convert 19 centimeters to millimeters and 19 centimeters to meters. I'm going to tackle the second one first. So this is essentially converting from a prefix unit to the unit alone. Now, let's say you know how many centimeters there are in a meter. And you should know how many centimeters there are in a meter. For instance, when I hold my hands 1 meter apart, I'm going to hold them 3 feet apart. That's 1 meter. Close enough. Now, for a centimeter, what should you be using as a centimeter? If someone on the street said, oh, how big is a centimeter? You should hold up your pinky finger and pretend to be Dr. Evil and go, it's about the width of my fingernail. That's 1 centimeter. What's 1 millimeter? Well, if you think about those mechanical pencils that have 0.7 millimeter leads, well, 1 millimeter is just a little thicker than that. So you can explain to people how these numbers work. Now, if I look at the width of my fingernail, how many of these are in this guy here? 10 doesn't seem to be enough. 1,000 seems to be too many. So how many centimeters fit into this? And the answer is 100. So we can write 100 centimeters is equal to 1 meter. But let's say you had no idea about that and you still wanted to get the conversion. Here's another way to get it. You have to memorize prefixes. I won't give you the names here. I'm just going to give you the symbol. You can look up the names. This is mega. It's 10 to the 6, which is a million. This is kilo. It's 10 to the 3rd, which is 1,000. This is deci. It's 10 to the minus 1. Centi is 10 to the minus 2. Lowercase m is 10 to the minus 3. Mu, and we call this micro, is 10 to the minus 6. N is nano, 10 to the minus 9. And P is pico, 10 to the minus 12. You should know at least these. So let's say you didn't know this. How could you get there? Using prefixes. And here's how you do it. Start with the 1 prefix unit is equal to 1 prefix unit. And the reason you start with this is because you know it's a fact. No doubt in your mind that this works. Now you take this prefix and you substitute that for it. And then if you don't like negative exponents, take this and put it on the other side like that. So I can write the 1 times 10 squared. And then if you don't like exponents whatsoever, then go ahead and write 100 centimeters is 1 meter. So do you see how I arrived at the same conclusion starting with 1 centimeter equals 1 centimeter? Okay. So here's my equality. Here's how I want to convert this. So I want to multiply by a ratio that has centimeters on top, centimeters on the bottom, meters on top. So clearly I'm going to put 100 centimeters here and 1 meter here. And the answer comes out to be 0.19 meter. And this is the work I would expect to see. I don't need to see the rest of it. I'm just showing you how to get the conversion. So this is one way to do that problem. Another way to do this particular problem is to do something called substitution. So here I've taken the C and I put 10 to the minus 2 in place of C because that C is just a placeholder for a number. And what I'm doing here is I'm putting the number there. And we get the same answer. So this would be fine for this particular problem, either or. You could also do this, and it's the same solution as above, but a little bit different. I'm going to use this one now. I use this one here. I'm going to use this one here. And the point here is that no matter what conversion you use, as long as it's correct, it'll give you the right answer. And it's going to be your job, your responsibility to become comfortable with metric conversions. If you're not comfortable with metric conversions on the exam, you're going to lose points, and I don't want that to happen. So become comfortable with that. All right. So I've shown you how to do this part, meters. Now let's do the millimeters. So let's say that you don't know the relationship between millimeters and centimeters, then this is what I would do. I would take centimeters, turn it into meters, and then meters into millimeters. And so for number 1 and number 2, number 1, I have this, 1 centimeter is equal to 1 centimeter. So 1 centimeter is 1 times 10 to the minus 2 meters. The other thing I should tell you is if you don't memorize the prefixes, you won't do well on the exam. Number 2 is 1 millimeter is 1 millimeter. 1 millimeter is 1 times 10 to the minus 3 meters. So these are my 2 conversions, and I don't need to write ratios because I can decide which one to put on the bottom based on starting right here. So which of these 2 sides am I going to put on the bottom? The left or the right? So here's where we're going to try another little trick. Can everyone see the arrow in your participant list that says faster and slower? Go faster, go slower. So if you think I should put the question is, which side should I put on the bottom? 1 centimeter would be go slower. 1 times 10 to the minus 2 meters would be go faster. So which side do you want me to put on the bottom? Left or right? Go slower is left, go faster is right. Okay, I got 3 go slowers, and that's correct because the centimeters will cancel. So that means that the other side goes on the top. So now here, for the next conversion, which side goes on the bottom? Left or right? Okay, and we're going to put the right side on the bottom so that the meters cancel, and we have 1 millimeter on top. And then I'm not sure if you know how to deal with exponents, but if I take this 10 to the minus 3 and I cross the line, it becomes 10 to the plus 3. 10 to the plus 3 times 10 to the minus 2 is 10. 10 times 19 is 190 millimeters. So this is perfectly fine. I don't need to see this work here, but I do need to see that. Another way to do it is this way. Do you remember how I said your pinky is about 1 centimeter? So those little 0.7 pencil leads, how many do you need to work your way across your pinky side by side? And it seems that about 10 of them would work here. Probably more than 10 because the leads are actually 0.7. They're not 1. So 10 pencil leads should fit across my pinky. So that means that 10 millimeters is 1 centimeter. So we could use this. Which side goes on the bottom, left or right? Okay, and that's correct. We're going to put the right on the bottom so that the centimeters cancel. 10 millimeters on top. And once again, we get 190 millimeters. So it is kind of nice to be able to know the relationship between different types of metric measurements. Okay, let's move on. Number 8, a compact disc has a diameter of 11.8 centimeters. what is the surface area of the disk in square centimeters and in square meters? And they give us that the area of a circle is pi r squared. So the diameter is 11.8 centimeters. The area is pi r squared. And it is a compact disk, which we know is a circle, of course, with that little hole in the middle. And this is the diameter. So if we want to use this formula, we're going to have to take the radius and get it from the diameter divided by 2. And half of 11.8 is 5.9. I plug this in here and get an estimate. This is about 6. 6 times 6 is 36. 36 times 3 is about 100. And 100 divided by 2 is 50. So the answer should be 50-ish if I'm thinking about this right. But I don't know. It's pretty late. My brain gets fried about this time of night. Oh, I made a mistake. It's not divided by 2. I added the 2 for some reason or other. So I'm going to get rid of that. And my calculator tells me it's 109.35. So where should I round this to? And if that has 2 zig figs, the thought is I should round it to here. And what I've just shown you is wrong. Okay, so the reason what I showed you is wrong is because we didn't follow significant figure rules. So let's do it correctly. So 11.8 has 3 significant figures. 2 is exact because the radius is defined as being half the diameter. It's really the other way around. 2 radii make 1 diameter. If that has 3 zig figs and this is exact, this should have 3 zig figs. So I have to put a 0 on the end. Three significant figures, at least 10. We're going to end up with 3. So you'll notice here that we have the formula. We put the numbers in and we show the result. Formula, put the numbers in, show the result. Are we okay with this one?
Yes.
Okay, we got 3. That's enough for me. Okay, some soft drinks are sold in bottles with a volume of 1.5 liters. What is this volume in milliliters? So I'm going to take 1.5 liters, turn it into milliliters. So I want the relationship between 1 milliliter and 1 milliliter. 1 milliliter is 1 times 10 to the minus 3 liters, and I'm good to go. So I'm going to put the right-hand side on the bottom so that liters cancel. And what's nice about this is I can go ahead and write my answer in scientific notation. (1.5 times 10 to the third milliliters). I have 2 zig figs here, 2 zig figs here. So this is an excellent answer to the question. We could have used this in other ways, but I'm just going to leave this one like that. In cubic centimeters, this is a conversion I would like you to memorize. because it turns out that 1 milliliter is defined as the volume that is equal to a cubic centimeter. This is defined. So on the first test, if you're asked a question calculated in cubic centimeters and you have something like this, I want you to write this out. For the second exam, third exam, fourth exam, I'll let you go between milliliters and centimeters cubed on the fly. But for the first exam, I want you to show me the calculation. Now, for cubic decimeters, not many people know the relationship between decimeters and centimeters, so I'm going to assume you don't. So what we're going to do is we're going to take our 1.5 times 10 to the third centimeters cubed. We're going to turn that into meters cubed and then that into decimeters cubed. So it's hard to know the relationship between meter cubed and centimeter cubed, but I want you to think about this for just a moment. What is a cubic centimeter? Well, the width of your pinky finger, where each edge of the cube is one of these. So if you can imagine a small die, that's 1 centimeter cubed. Now, what's a meter cubed? Well, if you have a washing machine in your place, take a look at that. That's about a cubic meter. So how many of these little tiny die can you fit into that cubic meter? And the answer is about 1 million. Let's take a look at that though, and let's see what we can do to figure that out. So this is a fact. And if I cube this side, I have to cube that side. And here, this is the same thing as what's in parentheses. And if I take this over to this side, I get 10 to the 6 centimeters cubed is 1 meter cubed, and that's 1 million. Now, this is a lot of work. Let me show you another way to do it, where we're going to use this, and I'm going to go ahead and use 100 centimeters is 1 meter. So let me show you how to use this and go from centimeters cubed to meters cubed. I'm going to need a little bit more room to work. So I'm going to write 1.5 times 10 to the third centimeters cubed times 1 meter over 100 centimeters. Now, this only cancels with one of those. So what am I going to do? And the answer is multiply by the same thing again. Remember, every time we use a conversion, we're multiplying by 1. So all I'm doing here is multiplying by 1 again and again. So these 3 centimeters are going to cancel that guy. Now, what about the decimeter in the meter? Well, 10 decimeters is 1 meter. 10 decimeters is 1 meter. So I can multiply by 10 decimeters over 1 meter times 10 decimeters over 1 meter times 10 decimeters over 1 meter. And we're going to get basically 1.5 decimeters cubed. So this is the way I would write something like this out. There are other ways of doing it that are appropriate, but I like this way rather than doing something like this. Okay, let's move on to the next one. A US dime has a mass of 2.6 2.65 grams. What is the mass in kilograms? So here I'm becoming a little more confident. So I'm going to take 2.265 grams and multiply by 1 kilogram over 1 kilogram. Because I know for darn sure that's 1. I'm going to keep this upper K, but this lower K, I'm going to change to 10 to the third. That way the grams cancel and I don't have anything, any unit on the bottom. And you can see that this ends up being 2.265 times 10 to the negative 3 kilograms. So there's your solution. So there are many different ways of tackling this. You have to find the one that you're most comfortable with that will also be successful. So 2.265 grams times, I'm going to do this one, milligram over milligram. And now I'm going to write. So let me make a mistake here so you can see how easy it is to recover. So I'm going to write 1 times 10 to the minus 3 grams over 1 milligram. And can you see how milligrams and grams does not cancel? So I went down the wrong road. So this time I'm going to put my 1 milligram on top and my 1 times 10 to the minus 3 grams on the bottom. And I get 2.265 times 10 to the third milligrams. So there's a wonderful solution for converting to milligrams. Okay, we have like 4 hardcore people in here. Let's do number 14. And since we already did 16, this will kind of catch us up to where we had kind of begun. A piece of silver metal has a mass of 2.365 grams. If the density of silver is this, what is the volume of silver? I'm going to show you 2 ways to do this. So I'm going to use the conversion factor method. So I want to take my 2.365 grams and turn that into centimeters cubed, a volume. So in a perfect world, I would have some equality or conversion factor that had grams on the bottom and centimeters cubed on the top. And I don't. I have 10.5 grams per centimeter cubed. Well, let's reverse engineer this. Remember, if we have an equality, we can take one side, put it on the bottom, and the other side and put it on top. So this means that 10.5 grams is 1 centimeter cubed. And I can put either side on the bottom and either side on the top. So I'm going to put 1 centimeter cubed over 10.5 grams. So I can use this as a conversion factor instead of this. So I'm going to put the 1 here and the 10.5, and that should work. Grams cancel. We're allowed 3 significant figures because of the 10.5. And so we get 0.225, 3 significant figures, centimeters cubed. And this is perfectly fine for doing this problem. And I'm going to show you one more way to solve this problem, and then we'll call it quits. You can actually use the formula for density. Density is mass divided by volume, which means volume is mass divided by density. So you can start with this, and then you can plug in the mass, divide by the density, and you come to the same result. I prefer this method because it makes a little more sense to me. Both are okay. So what you're going to do now is end the session. turn on your,
I was trying to reach you for your scheduled coach call, a part of your healthcare benefits. I'm sorry to miss you. Please return this call at your earliest convenience. Our toll-free number is 866-962-0957. We look forward to hearing from you. To avoid future calls such as this, please contact us toll-free 866-962-0957.
yay, my health coach call. Okay, so both of these are just fine. And now that we're done, hopefully I'll see you tomorrow evening or tomorrow sometime. Turn on your mics and say goodbye to everybody.
Bye.
Goodbye.
Can I ask a quick question about converting with prefixes?
Yes.
I'm just wondering, I sent you a direct message in the chat about converting decimeters to centimeters. I'm just wondering if I'm doing it correctly. I didn't know if you saw it.
How long ago did you send it?
I just 1 decimeter cubed is 1,000 centimeter cubes. I did that right, but what I'm doing for it is I take the larger exponent and I subtract the smaller one. Even if it's negative, it'll make it a positive. And then I use that number when I'm converting from like any of the prefixes to a different prefix.
You know what? Why don't we go ahead and let me pause this right now and let everybody else sign off, and I'll look for your email. And-
It was just a chat.
Oh, it's in the chat, you say?
Yeah, I just sent you a quick chat when we were going through.
Okay. Yeah,
Because
I
I
don't.
saw something online about how to convert from prefixes, and it made a lot of sense. I just want to make sure I'm doing it right.
Yeah, I don't look at chats because I've got so much open. So let me take a look at the chat. So what they're doing there is fine, but it's because of this. So we know that 1 decimeter is 10 centimeters. Okay, that's a fact. Golden rule of algebra, what I do to one side, I have to do to the other. So I'm going to do something that's wrong. That's wrong. So I'm going to start off with what is correct, and now I'm going to do it right. So if I cube one side, I have to cube the other side. I can't cube one part of a side. See up here, I only cubed the centimeter and not the 10. So this is how they get 1 decimeter cubed is 1,000 centimeters cubed. Now, I'm not sure what you mean by subtracting the,
So, like if I was going from like, I don't know, 1,000 millimeters to picometers, I would do -3, which is the exponent, minus -12. So -3 plus 12 is 9. So it'd be 10 to the 9th would be the difference between a millimeter and a picometer.
okay, so how would you write that out?
I would say like 1,000 millimeters times 10 to times 1. I would put the big number 10 to the 9th with a picometer.
Okay, so you're going to write,
So 10 to the 9th picometers is 1 millimeter.
okay, and that is correct.
Okay.
So as long as your conversion here is correct, that's fine. And here you get 10 to the 12 picometers, right?
Right.
Okay, so the way I've been teaching you is this way. You start off with 1,000 millimeters and multiply by 1 meter over 1,000 millimeters. And then you would write, the way I would do it is 1 picometer over 1 times 10 to the minus 12 meters. Because this one is that one, this P is 10 to the minus 12, that M is that M, so that's equal to 1.
I
When you
think
put this into your
converting it.
when you
Sorry.
put this into your calculator, can you see 1,000 divided by 1,000 is 1?
Right.
Meter divided by meter?
Yes,
happens
you
when
just
the-
bring up the negative exponent. And it's just
Yep.
10 to the 12. I feel like if the numbers were a little messier than 1,000, I think converting to the meter might just be more steps for me to make little mistakes.
Yeah, this is the one where you're probably going to make fewer mistakes than this one. But this does work.
So with the version that I did, do you always do the bigger one minus the smaller one? Like bigger is the tetra and pico. I mean, I don't know if you know this method.
I don't like the method, but you always do the difference. So what I mean is if you have 10 to the minus 9 and 10 to the minus 6, because here we have pico is 10 to the minus 12 and milli is 10 to the minus 3, right?
Right.
So you did minus 12 minus negative 3, which is negative 9, right?
Right.
Or you could do
Right. I
negative
just have to
3
keep it
minus a negative 12, which is positive 9.
right.
So you could say that
Okay.
there's 10 to the 9 picometers per 1 millimeter. Or you could say that there's 10 to the minus 9 millimeters per 1 picometer. These mean the same thing.
Right.
So you have to be careful about doing this. You asked, do you always subtract the smaller from the larger? This is subtracting the smaller from the
Right.
larger.
I just
So-
need to make sure that I put the large number with the smaller unit.
Absolutely. The larger number always goes with the smaller unit. Always. Just
Okay.
like here. Foot is larger than an inch, but 12 is bigger than 1. Bigger number goes with the smaller unit.
Perfect. Thank you.
Okay?
Yes. Awesome. Have a good night.
All right, Rebecca. Good night. Good night, Marco.
Hey, sorry, Tony.
ahead.
I just had a question about the upcoming lab.
Yes,
So do you need the graduated cylinder for that?
you do.
Okay, I ordered it, but it's still in the mail. I was wondering if it's possible to use the other beaker that came with the lab set from CR as an alternative.
No, that won't work. Do you have an estimated date of arrival?
No, it's not gonna be till next week.
The lab isn't going to be due until, well, I was going to have it due Friday. Why don't you wait for the graduated cylinder and go from there? Well, let me ask you this. Are you in town?
I live in McKinleyville, yeah.
If you want, you can go to CR tomorrow between 10 and 3 and borrow a graduated cylinder.
Oh, okay. That would actually be cool.
Okay, so you're going to go to the science building. Do you know where that is?
Yeah.
You're going to go to room 112 and ask for Allison.
Okay.
I'll send her an email saying that I told you could go borrow the graduated cylinder, but I'd still like you to have one to use for yourself.
Okay. Yeah, I actually used to work there for a work study. I know Allison.
Oh, you know Allison.
Yeah.
Okay, well then tell her that Tony said you could. She knows you're not going to lie to her.
Okay. Thank you.
Okay, Marco,
Have a good night.
have a good night.
Thank you.